Hey, you guys, I wanted to get on here. I know my Zoom this morning or this afternoon didn't go perfectly, so I wanted to get on here. The first thing you need to do, we're going to look at 2 and 5. The first thing you need to do is identify your variables, okay? So 89 degrees C, that's your T1. 0.67 liters, that's your V1, and 1.12 liters, that's going to be your V2. You're solving for T2. So what I like to do first is make this list of my variables, what I have and what I'm looking for, okay? So V1, T1, V2, and then our question mark is T2. This is your formula for Charles' law. So if I'm looking to get this variable alone, I'm going to divide both sides by V1. And so this is my expression, T2 equals V2 T1 over V1. And then I take these variables and I plug them into that equation here. You'll see that liters cancel and you get K for Kelvin. Now the question didn't ask for degrees Kelvin, it asked for degrees Celsius. So you actually have to convert back to Celsius. And I know what you guys are thinking. Why did we convert to Kelvin here and then convert back to Celsius at the end? Charles' law expression is built on Kelvin temperature. If you leave it in Celsius, the Celsius scale actually has negative numbers within it, and this expression does not work with those values. So you always have to convert to Kelvin, and then if you need Celsius, convert back to it by subtracting 273. So I hope that was helpful. I want to also look at number 5 with you. And so I'm going to erase this on my handy dandy whiteboard. But I am going to leave part of it here. I'm going to leave my list of my variables because those are going to be, I'm always going to have V1, T1, V2, T2. And then I'm going to fill in what I have. So on number 5, I'm just going to read it to you. Calculate the decrease in temperature when 2.00 liters at 20 degrees Celsius is compressed to 1 liter. So my initial volume is 2.00 liters. My initial temperature is 20.0 degrees Celsius, but I again need to add 273 to that, which would give me 293 Kelvin, okay? And then my V2 is 1.00 liters. I'm looking for a decrease in temperature, so that's actually the difference between T1 and T2, but in order to find the difference between T1 and T2, I have to know my final temperature, my T2. So again, I'm going to solve for T2, which would be V2 T1 divided by V1. And I'm going to plug those in. Liters cancel and I get Kelvin. So 1 times 293 is 293 divided by 2. And I end up with 146.5 Kelvin. This is not rounded for sig figs yet because it's not our final answer. Equals temperature 2. But since I'm looking for the decrease in temperature, so I'm going to call that delta T, decrease in temperature, change in temperature. And that's going to be the absolute value between T1 and T2, right? So it's going to be the total change in temperature between initial temperature and final temperature. So our initial temperature was 293 Kelvin, and I'm going to subtract my final temperature, which was 146.5 Kelvin. Now, the funny thing is here is this works out to 146.5 Kelvin as the temperature difference. Now I need to round this for sig figs. So this is going to be 147 because all of these values in this expression have 3 significant figures. 147K is your difference in temperature, your decrease in temperature. Again, I know what you're thinking here. If I got 146.5, that also rounds to 147. It just so happened that the temperature in this problem halved. It went from 293 to half of that. So the difference equaled temperature 2, but that's not going to happen in every case. So make sure that whenever you're asked for the decrease or the difference in temperature that you go through and do this final step of subtracting. The other thing I want to talk about is evaluating your answer. You know, volume and temperature are inversely related, right? So as temperature directly related. As temperature increases, volume should increase, right? As temperature decreases, volume should decrease. And why is that? Assuming everything else stays constant, if particles are moving faster, they're going to take up more space. If particles are moving slower, they tend to take up less space. So let's evaluate and make sure that our answer makes sense. If my initial volume was 2 and my initial temperature was 293, and I decrease my volume by half, should my temperature also decrease by half? Well, if temperature increases, volume increases. If temperature decreases, volume decreases. If I half my volume, I should half my temperature. So yes, our answer does make sense. So I just wanted to go through that and make sure that you understood, because questions 2 and 5 are the ones that I had the most questions about throughout the week. I'll be doing a similar review over Boyle's Law next week. So please let me know if you have any questions. Thank you, guys.